Part two of it's what I was talking about was the part two of the prep assignment. So it's like the second section of it.
Okay. Hey.
So it's like you have part.
Oh,
yeah, go for it.
Sorry. So right now I've got you up on my laptop. I got the invite on my phone. So do you mind if I pull you up on my phone really quick? Just it makes mobility a little bit easier, and I can show you my screen.
Yeah, that's fine.
Okay.
Sometimes it runs better on the phone.
Oh.
Okay. Yeah, because I had to do that for another class because the Hangout wouldn't work on my computer, but it would work on my phone, so it's all good.
Alrighty.
Oh. So did you have any, let's do this first. Did you have any particular questions about this section?
I didn't look over the preparation assignment. I was trying to, but the laptop had an update, so I didn't really get a look over it that much.
Okay.
So is this the part two that you're talking about right here?
No. So in step one, where it says preparation assignment at the top, and it says answer key. So click on that and open that up. And so you see how it says like part one up at the top?
Yeah.
If you scroll down a little bit, it has part two as well. That's Tuesdays.
So, and that's what we're supposed to do together, and then.
I think so. That's what I was kind of understanding from the directions. But I like going over it first and then just reviewing it again.
Okay. Put the questions on part two. All right. I don't know. I guess we'll email them then, and then ask them like, is that actually for a grade, or is that just so that we're prepared for the meeting?
Mm-hmm. And so this is what I do. That whole worksheet. I usually do part one and part two before we meet, and then if I have questions, that's where I pull them from more because it's the application for what we were reading.
Okay, because I mean, they do provide the answers for part two, I think.
Yeah.
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 All right. 5. All right. Well, I guess we can, if you want, we can go over that really quick then, or do you want to?
Yeah.
All right.
Yeah, we can just go over it really fast. I did a lot of it, and at first I was getting really confused because I had a formula wrong that I was working from. But I think I've got it down because for the, what is it called? When you're trying to find the, I can't think of anything. When it's asking for the probability for the mean, I was forgetting to do the square root of the sample size. Part of the equation.
Okay. All right.
Let's see.
That's the book really quick.
And so, do you want to just start going over part 2 then of
Yeah.
this?
Sorry, I was trying to bring up the online textbook. Yeah, let's
No,
go.
you're fine. Okay. So for number 4, I got that it's the shape of the distribution is normal because it tells you basically because the parent population is normally distributed.
Okay.
And then for number 5, I got normal distribution as well for the shape of the sample. 1, because it's greater than 30, so even if the parent population had been skewed, it would have been normal. Also because the parent population was already normally distributed.
Okay. Number 5, right?
Yeah, that was number 5.
Okay. So I'm just glancing at the answer key, just kind of see what they said, and that pretty much looks like it. As I was talking about, like the sample size is large, the standard deviation of the sample mean will get smaller as well.
Yeah.
Numbers.
Because that's going to be the large number law of large numbers.
Yeah. All right.
And then central limit theorem is if the population sample is large enough, then it'll be normally distributed. So if it's larger than 30, is what we read from the last section.
It'd be normally distributed.
Mm-hmm. Yeah, so with central limit, it's no matter the distribution of the parent population, if you have a large enough sample, the distribution of the sample will be normal.
Yeah. Yeah. I remember that last time in our last assignment.
Yeah. All right. And then
Okay, so then 6 are normally distributed.
so number 6, it's asking for the probability that X bar is less than 40. So I found the z-score for that sample, and I got the z-score to be -1. And I plugged that into the applet, and I got the probabilities that it's less than that is about 0.16.
It's what? Sorry, the probability is less than what?
So it's I got the probability to be 0.1587 because I found the z-score to be -1.
Okay.
And then I plugged that into the applet that we have to find the probability.
To see if X bar is normally distributed.
No, so for number 6, it's asking us, so it gives us a sample size of n equals 4 is taken from
Sorry, I was looking at the wrong one.
Okay.
I was like, oh wait, no, this isn't less than 7. I'm sorry.
No, you're fine.
Okay. That makes a lot more sense now. Okay, so 6. So the samples of size n equals 40 are taken from the normally distributed
So the sample size is n equals 4. And then we're trying to find the probability that x bar is less than 40. So then I got a z-score of -1. And then I just use the applet to find the probability.
Okay.
For that one.
Okay. And then the shape came out to be normal for you then?
Say that again?
The shape came out to be normal for you then?
Well, the shape is normal because what is it? Question
sample size.
9.
Yeah.
That is already normally distributed. So it's going to be normal.
Yeah.
And let's see.
I mean, you can already say that though because the sample size is greater than 30 in the first place.
But the sample size isn't greater than 30 for that question.
On 6?
Because the sample size is 4. Yeah, sample size is 4.
Oh, okay. Okay.
So whatever n equals, that's your sample size.
Okay. Yeah, my bad. I was looking for it. Okay, sample size of 4. Okay. What is the probability of observed? X bar is greater than 4. All right, I get it now.
All right. And then for number 7, I got so the z-score I got for it being greater than 35 to be -2 and less than 55 to be +2. And because of the 68, 95, 99.7 rule, it's 2 standard deviations away. So it would be the 95% probability that a number would fall in between. The value would fall in between those numbers.
Okay.
If that makes sense. Because that had me confused a little bit when I was first going back because I kind of forgot like what the z-score actually is. So it's like looking back.
Okay. Yeah, I think I'm still a little bit confused with the 68.
95, 99.7 rule.
Yeah.
Right? Because all that rule is saying that the probability of the value falling between 1 standard deviation out of the mean is 68%.
Mm-hmm.
The probability that it's going to be I've forgotten my words. 2 standard deviations outside, okay. So that's 95%. And then 3 standard deviations is 99.7% of the time. it'll fall within 3 standard deviations.
Okay. So then, by what you mean with that, so like for example, if like the number is 35, then it falls under the 68%, which is 1 standard deviation, or?
So if it's, let's see. So like the times that it's going to be most like applicable to use that rule is so when you find your z-score, like on number 8, when you're trying to find what's the probability that x bar is greater than 41 but less than 49, you have to find the z-score for both of those values, and it's 2 and -2. And so that's the number of standard deviations away. So it's saying that 41, so if x bar falls between 41 and 49, that's 2 standard deviations away from the mean. So that's 95%. That had me really confused at first.
All right.
I don't know if I explained that any better.
It's making more sense now. Just, I don't know. I just think I need a second just to kind of. Okay. So then with like 41, on 8, like you said you needed to find the z-scores for both of them. So then
Yes.
you plug them into the formula, which is value minus mean divided by standard deviation, right?
Yes. And so
Okay.
under this section is value. So x bar minus mu divided by, I can never remember what that stands for. The standard deviation divided by the square root of n is how we're finding the.
To get the z-score. Okay.
That's, yeah, so that is, let me look at what it says exactly. Yeah, because in the book, at the beginning, it says that the standard deviation for random variable is going to be the standard deviation of the sample of the sample divided by sample size.
Second, sorry.
No, you're fine.
Okay, what the thing I think I'm struggling with here is we're only giving you the sample size n equals 4, but like with your equation you've got x bar minus mu divided by standard deviation which is divided by root of n.
Yes.
So like since they're only giving you n and 41, like how are you finding like the other
Okay.
standard deviation?
How I'm finding the mean and the standard deviation?
Yeah.
Okay, that is actually given to us, question 4. So it's talking about pair computing. It says they sold an average of 45 or whatever phones per minute in 2011 with a standard deviation of 10.
Oh, okay.
So
I
we're
see it.
still using that same information to answer the rest of the questions.
Okay.
So I'm using the mean of 45, the standard deviation is 10, and then I just plug in
Okay.
whatever the value is and the sample size. So
All right.
to plug.
Okay. Yeah, I missed that part. Awesome. Thank you. Sorry.
No problem.
That makes it a lot easier to work. Okay. So
Exactly.
then once you plug in those numbers and you get your answer for your z-score, you plug your z-score in, and then you look at your area, right? And then your area, for example, on
It's the
8.
probability.
Yeah, your probability. Okay. So then z-score equals -2. Hold on. Let me pull the normal probability after because I kind of want to just see that part with my own eyes really quick.
Okay.
So you said that when you worked it out, you said that the answer came out to be -2 for your z-score.
Yeah, so you find two z-scores
Uh-huh.
because they give you two values. And so they end up being -2 and 2. And so if you plug it into the applet, the probability is going to be 0.9545.
Yeah, you shade it between the two, right?
Yeah, so you shade it between the two, and that'll give you that probability. Or because of the 68, 95, 99.7 rule, you can say that the probability is 95% because it's two standard deviations away from the mean.
Okay. Alrighty. Yeah, that makes a lot more sense now. I'm gonna get it. It's a lot easier. So you find out whether it's 68, 95, or 99.7 by just finding the z-score of the equation, and then.
So if you have like a z-score of 1, it's going to be one standard deviation away, so it's 68% in between. If it's 2, then it's and then
2, 3. Okay. Cool. 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 All right. Moving on.
right. For number 9, I got my z-score as 2.5, and then I plugged in. I got my probability to be 0.00621.
Okay. And it was just following the same exact process or procedure as before. Alrighty. So with it being 5/2, like how would you plug that into the?
You just make it a decimal.
Okay.
So because you just make it a decimal and then plug it in.
Okay. All right, I get that now. And so then with, I guess, moving on, since that follows the same procedure, going to 10.
So for 10, I got right skewed because the parent population is already right skewed and the sample size is small.
All right.
And then for 11, I got approximately normal because the sample size is large enough. So along with 12, it's because of the central limit theorem. But it would be approximately normal.
Because the size is greater than 30.
Mm-hmm.
Easy enough. And then, yeah, using the central limit theorem, that makes perfect sense.
Mm-hmm.
So then sample size of equals 4 is taken from the right skewed probability that the observed. And then with 13, just glancing at the answer key here, I'm assuming you got no, that the distribution's not normal. And that would be just because the sample size is and kappa is only for normal distribution. Okay, so since that sample size n equals 4 is right skewed, you obviously can't do it because it's not the normal probability applet's not a right skewed applet.
Exactly. So if we had a larger population sample size that was 30 or greater, then we would be able to, because it would be approximately normal.
All right. Okay, and then, but for example, with 14, you could use, even though you're taking it from a right skewed sales data, you could still use that for the normal probability applet, right? Because it's greater than 30.
Mm-hmm. Yeah, because the sample size is large enough, we're able to.
Yeah. And then so you plug it into the formula, and then you get your z score of negative 1.75, and your probability comes out as 0.9599, right?
Yeah.
Nice. Okay, so then, oh, okay, yeah, all makes sense then. Negative 1.75. I just want to plug it into the greater than. Okay, that makes sense because it says in the equation greater than 36.5. So you're gonna shade in the middle and shade to the right. Yeah.
Yeah.
All right. With it being greater than. N equals 36 taken from the right. X bar is between. Okay, and then for example with 15, you're gonna shade between the two numbers because it said, what is the probability that the observed X bar is between 37.5 and 42.5? So shade in between your two Z scores. Okay, cool. That was easy enough. Once I got it.
It takes a little bit. Did you have any other questions?
No. I think I got it all.
Sounds good.